Now let's talk about some programming best practices. Your C++ program will be used by other programs, other humans. So it might need to be modified later to enhance it or to fix some errors. So for this reason, it's important to have it be easy to read. We use indentation in C++ programs to visually make the program easier to read, to make it more intuitive. The indentation is not important for the compiler. The compiler ignores the indentation. It is really needed by the people. Now, this is different from other programming languages that you might learn later. For example, Python depends on indentation and how to interpret your program. So for now, we want to make sure that the body of the main function is indented. So the body being what's within the curly braces. And we want to indent it by a consistent 3 or 4 spaces. So in this case here, I have indented it by 4 spaces. This makes it visually easy to read. It lets me know that these two statements are part of the main function's body. The other thing we do is we add comments to the program. The comments are used to explain sections of the program to other people. It explains the logic of what you intended to do in that part of the code. Just like indentation, comments are also ignored by the compiler. Now, a comment in C++ starts with a slash slash, as we have seen, and runs till the end of the line. Now, what if you wanted to have a multi-line comment? Alternatively, you can enclose your comment in a slash asterisk and asterisk slash, allowing you to have multiple line comments. So here's an example where we have a couple of comments that are the slash slash variety, but in the top here you have a multi-line comment, right? The only thing you have to be careful about is not to forget the terminating asterisk slash, or it might inadvertently comment out a whole section of your program. Now, you should not expect your program to work on very first try. You will make logical mistakes, you will make typos, and an important part of programming is learning to identify those and learning to troubleshoot and fix these mistakes as you progress. You will basically see 3 types of problems. There'll be compile time errors, runtime errors, and logical errors. So let's talk about each one of these. Compile time errors, they block your program from compiling. These are the best kind because they catch the error early. So what are some examples of these? Examples are missing trailing curly brace, missing a double quote, missing a semicolon at the end of a statement, right? And typos that you might have made, calling main, misspelling main, because main is a recognized word by the compiler, right? Or forgetting the trailing or the leading comment symbol for a multi-line comment. Now, runtime errors are only discovered when the program executes. So in this case, the program will compile successfully, but only have a problem and run when it's running and crash. All right. Such errors are not great to deal with because you're already starting to run your program and they are not caught early and sometimes can be difficult to fix. Examples that we will see more later in the course, because you need to know some advanced concepts, are division by zero. If you have an expression such as this, where x is a variable that we'll get to learn about soon, and the variable happens to hold the number 0 at a certain point in the program, you will have a division by zero error. There are other types such as segmentation fault, which is referring to a non-existing memory, or stack overflow is using up all your stack memory, or other examples that we learn more about. Now, logical errors in your program are the hardest to find. In this case, the program compiles and even runs fine without crashing, but behaves incorrectly, not as you expected, right? So in this case, something's wrong with your logic, something's wrong with your algorithm. Right? Examples here are: suppose you develop a sorting algorithm and doesn't quite function, doesn't quite sort properly, or you develop a search function through a collection of data, and even though data exists, it doesn't find it because there is a logical problem with your program, right? So what do you do in this case? Now you would have to what's called debug the program and find the error. How do you find these runtime and logical errors? So at this stage, what we should focus on are two approaches. First is we would insert print statements in our program to debug those logical errors. You would put print statements where you suspect the program is having issues. You might want to print some values to see whether they are as you expect. The second thing you can do is get to know your IDE a little bit better. Your IDE has a lot of debugging support. Specifically, it allows you to set a breakpoint in your program, and which allows your program to execute line by line, but stop where you've set your breakpoint so you can inspect what is going on before you proceed. We'll learn more about that as we proceed through the course.